Radius of curvature for polar tangential equations. It is given by rho equal to P plus d2P divided by d psi 2. So let's understand this by some examples. Question number 1. Find the radius of curvature for ellipse P square equal to A square cos square psi plus B square sin square psi. So we can differentiate this equation with respect to psi. It will become 2p dp upon d psi equals minus 2a square cos psi sin psi plus this will become 2b square sin psi cos psi. Here we can divide each term by 2. So we will get p dp by d psi equal to cos psi sin psi can be taken common. So it will become b square minus a square times cos psi sin psi. Again, we can differentiate it with respect to psi. Here we can apply product rule. So p times d2p by d psi 2 plus dp upon d psi 2 times. So we can write it dp upon d psi whole square. Now, here RHS will become b square minus a square times. We apply product rule. So sin psi will give cos psi. So we can write it cos square psi and then this will give minus sin psi. So it will become minus sin square psi. Now we can shift this term to RHS. So p times d2p divided by d psi 2 equal to b square minus a square times cos square psi minus sin square psi minus this term dp by d psi whole square. So dp upon d psi from here will give b square minus a square cos psi sin psi divided by p. So we can put this value here. So this will become b square minus a square times cos square psi minus sin square psi minus b square minus a square times cos psi sin psi divided by p whole square. So it will become, further we write, b square minus a square times cos square psi minus sin cos square psi minus sin square psi times. If we take LCM, p square will get multiplied to this and p square is question itself. So we can write it here. A square cos square psi plus b square sin square psi minus this thing b square minus a square whole square times cos square psi sin square psi whole divided by p square. 1p is here also. So if we want to get d2p by d psi 2, so this will become p cube. So we can write d2p by d psi 2 equals, from here, this term is b square minus a square whole square. Here it is b square minus a square. So one b square minus a square can be taken outside and this p will make it p cube. So we can write it as b square minus a square divided by p cube times cos square psi minus sine square psi times a square cos square psi plus b square sine square psi minus, since it was b square minus a square, so 1 b square minus a square will be left. So b square minus a square times, and here we have to square this. So it is cos square psi, sine square psi, because this was whole square. So cos square psi, sine square psi. Further, we open the bracket. So we will get b square minus a square divided by p cube times. We multiply this. A square times cos power 4 psi. A square cos power 4 psi. Then cos square psi is multiplied to this. So this will become b square cos square psi sine square psi. Then we multiply these two. So minus a square sine square psi cos square psi. Then this gets multiplied to this minus b square sine power 4 psi. This is multiplication of these two terms minus. If we multiply this, so minus here in there is minus sign, so minus b square sine square psi cos square psi, and then this minus minus will become plus plus a square cos square psi sine square phi. Now let's see which term gets cancelled. A square sine square psi, this term will get cancelled. B square, this term will get cancelled. So what is left? So we are left with b square minus a square divided by p cube times a square cos power 4 psi minus b square sine power 4 psi. We have got 12 of d2p by d psi 2. We need radius of curvature, that is given by p plus d2p divided by d psi 2. So we have to add p to this. So b square minus a square, here we write radius of curvature. So b square minus a square divided by p cube. A square cos power 4 psi minus b square sine power 4 psi and plus p. So here, if we take LCM, this will become p power 4. So we can write it b square minus a square times a square cos power 4 psi minus b square sine power 4 psi plus p power 4 divided by p power 4. Sorry, divided by p power 3. And in our question, we are given p square equal to a square cos square psi plus b square sine square psi. So whole square of this can be put here. So we will get a radius of curvature equal to b square minus a square times a square cos power 4 psi minus b square sine power 4 psi plus, we can write square of p. So p square will be a power 4 cos power 4 psi. So we can write it a power 4 cos power 4 psi plus b power 4 sine power 4 psi plus twice of a square b square cos square psi sine square psi divided by p cube. Now we have to open the bracket for this. and then we will simplify. So we will get a square b square cos power 4 psi minus b power 4 sin power 4 psi minus a power 4 cos power 4 psi plus a square b square sin power, this is a square b square, then sin square psi. Here we have multiplied b square, a square cos power 4 psi, then b square b power 4 sin. Now a power 4 cos power 4 psi. Now a square b square sin power 4 psi. Now further, we write expansion of this. So here we have already written it. A power 4 cos power 4 psi plus b power 4 sin power 4 psi plus twice of a square b square cos square psi sin square psi divided by pq, whole divided by pq. Now a power 4, this term will cancel out, this term will, and this term will cancel out. Now we are left with here this term, and this term. So let's write it further. This will become rho equals. We can take out a square b square throughout common. A square b square, then cos power 4 psi from here, sin power 4 psi from here, and twice of this last term, plus twice of sin square psi cos square psi. So divided by pq. This will become 1 because this is cos square psi plus sin square psi whole square. So we will get radius of curvature equal to a square b square divided by pq. So this is required answer. Now question number 2. Prove that for the curve with the usual notations, rho equal to r cosec phi divided by 1 plus d phi upon d theta. So if you remember, we have done in one question like this. So here there is curve whose tangent is point. This is r theta, and this angle is phi. This angle is theta, and this angle is psi. So this is r. So here we can use external angle theorem. So that is equal to psi equal to theta plus phi, and we differentiate it. So d psi upon ds. Here we are differentiating with respect to s equal to d theta upon ds plus d phi upon ds. Now we can write it further. D psi upon ds equal to d theta upon ds plus, here we write it d phi upon d theta into d theta upon ds. We can take out d theta upon ds. Then inside the bracket, we will be left with 1 plus d phi upon d theta. Now, we know that ds upon d phi is radius of curvature rho, So we can make use of it. And also we know if triangle is like this is r d theta, and this is ds, this is pi, and this is dr. So from here, r d theta upon ds, if we find r d theta upon ds, that will be sine phi. So d theta upon ds, we can write from here as sine phi upon r. So, and this will be equal to, since ds upon d phi equal to rho, this is just reverse. So 1 upon rho equal to d theta upon ds. From here, it will be sine phi upon r times 1 plus d phi upon d theta. So rho equal to, this will become r, this we can write it, invert it. So this will become cosec phi divided by 1 plus d phi upon d theta. And that is our answer. Let's take one more question. Rho times r d theta upon ds whole square minus d2r by ds2 equal to r d theta by ds. So again, same triangle we can consider. So as we know, psi equal to theta plus phi, or phi equal to psi minus theta. And also in the triangle, this angle is phi, this is r d theta, this is ds, this is dr. So dr upon ds gives cos phi. So wherever need will be there, we will put this value. So let's start from here. Dr upon ds equal to cos phi. We differentiate it once again with respect to s. So d2r by ds2 will be equal to minus sine phi into d phi by ds. And phi we can replace by psi minus theta. So d2r by ds2 equal to minus sine phi and d upon ds of psi minus theta. So this will become minus sine phi times d psi by d theta, sorry, d psi by ds minus d theta by ds. And we have studied that r d theta by ds equal to sine phi. So sine phi we can replace, sine phi will be equal to r d theta by ds. So here we write d2r by ds2 equal to minus, and this will become r d theta by ds, and times d psi by ds is, remember, ds upon d psi is the radius of curvature. So this is 1 upon the radius of curvature, 1 upon a rho, minus second term d theta by ds. Now we can write it further. This will become r negative d theta by ds times 1 upon a rho plus r times d theta by ds whole square. This is d2r by ds2. Now we can take this term to LHS. So r, let's delete some portion here. So it becomes r d theta by ds. This term we are taking to LHS into 1 upon rho and this term remains in RHS r d theta by ds whole square, and this term goes to RHS minus d2r by ds2. So our concern is to get r d theta by ds, r d theta by ds. So rho will get multiplied. So rho times this thing, r d theta by ds whole square minus d2r by ds2. And this is our required result. Thank you for watching.